Welcome to our program. We're talking to Dr. Stephen Meyer, philosopher of science who got his PhD at Cambridge in England. He's written a best-selling book, Signature in the Cell, that we've been looking at in past programs, DNA and the Evidence for Intelligent Design. And what we have seen is that if you look at the cell, you got trillions of cells in your body, those cells are so filled with information. And we've looked at some of that information, and that screams for an intelligent designer. That's what the evidence shows when you look through the microscope. When you look through the telescope, which is where we're going now, I think you're going to see design there as well. But that's not the worldview that's at large. We've got new atheists like Richard Dawkins, who wrote The God Delusion, Christopher Hitchens, God is Not Great, Sam Harris, The End of Faith, and others. Richard Dawkins has said, everything, whether here or other worlds, where you see intelligent design, it's not really an intelligent designer that's doing it. There is no intelligence out there. It's an illusion. Now, Stephen, when you were working on your PhD at Cambridge, you investigated that worldview and compared it to how science actually started. Talk about that.
Well, it's really been a kind of a lifelong journey in investigating these big questions and the relationship between science and the larger worldviews that we humans formulate to make sense of our experience. And what Dawkins is saying is that science properly understood undermines belief in God. It challenges belief in God. And his argument runs something like this. He says that the strongest argument for believing in God was always the argument from design. When Darwin came along, we came to understand that there is no design in nature, only the illusion or the appearance of design. And therefore, belief in God is tantamount to a delusion. And that's the title of his famous book, The God Delusion. What strikes me about that is just how at odds his perspective is with the perspective of the scientists who actually founded what we call modern science. If you go back to the period of Newton and Kepler and Boyle and Galileo and Copernicus, the period that historians of science call the scientific revolution, the concept of design, intelligent design, was actually part of the foundation of the whole scientific enterprise. The scientists at that time had a watchword or a kind of a motto, and it was the idea of intelligibility. They believed that they could study nature and make sense of it because it was intelligible to the human mind. Why? Because it had been designed by a rational intellect, namely, in their view, the Judeo-Christian God.
Give me a few examples.
Well, there are many scientists who had this perspective, but take, for example, the founder of modern biology, John Ray. In his book, it was actually titled The Wisdom of God Manifested in the Works of Creation, which was a paraphrase of a passage in the book of Romans in the Bible that affirms that from the things that are made, the unseen qualities of the Creator can be known, including His wisdom. You find this perspective in physics as well. In fact, there's a whole series of scientists that express this. Johannes Kepler said that we as scientists have the high calling of thinking God's thoughts after Him. What are we doing? We're perceiving the design, the order, the structure that He put into the universe, the mathematical harmony that was put into the universe. That was Kepler's perspective. I think this perspective reached, in a sense, a kind of magisterial epitome in the works of Newton. He wrote in both the Optics, his famous work on the eye and light, and in his most famous work of all, the Principia, he made design arguments. So many scientists assumed design. Newton wanted to establish it by the evidence based upon what you might call the fine-tuning of the arrangement of the planets in the solar system. He was aware that gravity provided a force that was being harnessed to keep everything going, but he also realized that the forces of gravity that were in play from one planet to another and the sun to the different planets were so complicated that it was very difficult to imagine how you could get all those forces to balance to maintain a stable orbit. So in the Principia, he actually argues that the best explanation of that fine-tuning of the planetary configuration is the design of an intelligent and powerful being with a capital B. Here, let me read you the quote. It's very elegantly stated. He says, "Though these bodies may indeed continue in their orbits by the mere laws of gravity, yet they could by no means have first derived the regular position of the orbits themselves from those laws." He's talking about what physicists today call initial conditions. They're finely tuned to allow for this system to be stable. Thus, this most beautiful system of the sun, comets, and planets could only proceed from the counsel and dominion of an intelligent and powerful being. This is Newton's argument in what is arguably one of the greatest works of physics ever written. It's right in the structure of his case. So it raises for me a kind of curious question when I listen to Dawkins, which is, how do we get from Newton and Kepler and Galileo and Copernicus, from those guys, with their perspective that design is not only necessary for doing science, but evident in the natural world, to these modern new atheists who say that science has shown there's no design and therefore belief in God is delusional?
All right, Stephen, let's answer that question. How did we get from Newton to Dawkins?
It really is the story of 19th century science and what began to change. The first part of it has to do with a man named Laplace. He was a French physicist who wanted to show that you could do what Newton said you couldn't do, which was explain the origin of the solar system itself as a result of purely undirected natural forces without recourse to any designing intelligence. He wrote a book called The Celestial Mechanics that became a great classic in physics, in which he attempted to do that. He apparently was called before Napoleon to receive commendation for making French science proud as a result of publishing this book. And as the story goes, Napoleon tells him, what a wonderful job he's done. He showed up the British and wrote this great book of science. But he noticed that he didn't mention God in his scientific works, and yet Sir Isaac Newton had mentioned him on nearly every page. And Laplace is said to have kind of puffed himself up and said, "Sire, I have no need of that hypothesis." And we don't know if this is actually true, but it became emblematic of what would unfold in the 19th century as science explained more of these great events in the history of the cosmos, these origins events. Laplace attempted to explain the origin of the solar system. Lyell came along in geology and attempted to explain the origin of the great geological features as a result of the outworking of slow, gradual, naturalistic processes, whether the mountains or the canyons or what have you. Then Darwin came along and explained the origin of the new species from simpler pre-existing species. Scientists followed him, attempted to explain the origin of life, those we've talked about in previous sections of the show, not so successfully. But by the end of the 19th century, there was this perspective that there was that you could have a completely seamless naturalistic account of the whole of the universe, from the origin of the solar system to the origin of the planet Earth and the canyons, to the origin of life, to the origin of new species, even to the origin of man, as Darwin extended his idea of evolution to account for the human species. So it was a kind of a seamless naturalistic account. And one scientist has said of Darwin that he helped establish this materialistic worldview. Douglas Fatuma, in a standard evolutionary textbook, says, by coupling the undirected, purposeless variations to the blind, uncaring process of natural selection, Darwin made theological or spiritual explanations of life superfluous. He had no need of that hypothesis, just as Laplace had no need of it. So by the end of the 19th century, you have not only a series of theories about origins, you have a kind of comprehensive worldview that gives a full account of where everything came from without any recourse to a designing mind, to a creator, to God, any external agent of any kind. And so, that's how we got from Newton to Dawkins. And Dawkins, in talking about the new atheism, is really recycling the perspective of the late 19th century. So,
all right, we're going to take a break. And when we come back, we're going to turn the corner. We're going to talk about the new scientific evidence that refutes the materialistic, naturalistic worldview and refutes the new atheists and what they're saying, that there is no evidence of design when you look at the universe. We're going to talk about that, and he's going to lay it out for you. And stick with us. We'll be right back. All right, we're back. We're talking with Dr. Stephen Meyer, philosopher of science, and we're talking about what is the materialistic worldview and what is the scientific evidence that is starting to refute that?
Well, if you think about what we were talking about in the last segment, how the scientists of the 19th century had developed a series of ideas about how all the big things in the universe arose. They had an explanation, or at least so they thought, for the origin of the solar system, for the origin of the great geologic features, the origin of new forms of life, the first life. They had this seamless materialistic account. But if you were to ask a question about that, there was one unanswered question, and it was, well, where did all the matter come from in the first place? Where did all the particles and the gases come from that were necessary to build even the solar system? Well, that didn't bother scientists in the 19th century so much because they assumed that the universe was infinite, that it had always been here. So if you want to tell the story of the cosmos, you go back from human life to simpler life to the first life to the chemicals out of which the first life was made to the elementary particles, and those have been here from eternity past. And so the materialistic worldview could be summarized in a kind of a little credo that runs something like this. From eternity past were the particles. Not in the beginning was the, but from eternity past were the particles. And the particles arranged themselves and became more complex stuff, more complex chemicals. And the chemicals arranged themselves and became the first living cell. And that eventually evolved by undirected materialistic processes, namely natural selection, and that cell became more complex life. And those living forms eventually conceived of the idea of God. They became aware first and then conceived of the idea of God. So in the materialistic worldview, there is a place for God, but God is a concept in the mind of one of the evolved forms of life, namely us, but God has no reality, and what is fundamental, what is the thing from which everything else comes, is the particles, is matter and energy that has been here from eternity past. So that's a perspective that's not just based on certain scientific theories, it's comprehensive, and in that sense it's a kind of a philosophy or a worldview, a comprehensive way of looking at everything.
Very clear picture of the materialistic view. Now, let's get into the stuff. What's the new science that is destroying that?
Well, remember, one of the key premises then in this worldview is that matter and energy are eternal and self-existent, and then also self-organizing. But the fabulous, extraordinary discovery of modern cosmology is that the universe is not eternal, that it's not always been here, that time is not infinite in duration going all the way back. And what first made scientists aware of this was things that they were seeing through the telescopes, the dome telescopes that came on the scene in the 1920s. And this is a photograph of Edwin Hubble, for whom the Hubble telescope of today is named. Hubble began to work in astronomy at a very propitious time, right in the 1920s, as these great dome telescopes were being designed and created. And as a result of these telescopes, they could capture a great deal of light coming from the night sky, and we're able to resolve little tiny pinpricks of light that previously we couldn't make out. And before the 1920s, there was a debate among astronomers as to whether or not the Milky Way, the galaxy in which our solar system resides, was the only galaxy or not. What Hubble discovered was, first of all, that there were many galaxies in every quadrant of the sky. And I've got some photos of some, they're absolutely beautiful. Mm-hmm. There he is at his telescope having a look, and he's got Spindle Nebula that he discovers. Some of these are some of his original photographic plates, Spiral Nebula, sketches that he made of these beautiful galactic phenomena. And now we know that as you look at any quadrant of the sky in which you choose to focus, and then you magnify that, this is what's called the Hubble Deep Field, even the tiniest little quadrant is just chock full of galaxies in every direction. So it's an immense and enormous universe. That's the first thing he discovers. But the second thing is even more significant philosophically and scientifically, and that is that the galaxies, the light coming from these galaxies, is shifted in the electromagnetic spectrum, from red to violet. It's shifted in the red direction of the spectrum, indicating that the light is coming from objects that are receding, that are moving away from us very fast. Some of your viewers would probably remember the Doppler effect, wherever it was sound. If you have a train recede from us, the pitch of the train goes down. Same thing happens with light. If an object is receding, the wavelength stretches out, and longer wavelengths correspond to the red end of the spectrum. So light that's shifted in the red direction is indicating a recessional velocity. The thing is moving away from us. And what Hubble discovered was that no matter which quadrant of the sky we look, we find galaxies that are moving away from us. And that led to an amazing, amazing conclusion, which is that the universe is expanding. And it's expanding outward in all directions. It's a kind of a spherical expansion, if you will. And I've got a way of illustrating that, if you will. Okay. And this is a simple balloon. But the idea, if every galaxy is moving away from us, And if the further away it is, the faster it's going, which is something else that Hubble discovered. The only way to make sense of that is that the universe is expanding in a spherical way like this. In other words, as you're going in the forward direction of time, the galaxies are moving further away from each other, and the universe is expanding. Okay, real simple illustration. Kind of an oval-shaped universe here. But anyway, what happens though, think about this. What happens as you begin to back extrapolate, as the scientists say? As you begin to think about what the universe would have been like 1,000 years ago, or 100,000 years ago, or a million years ago. You go back as far as you want, and at each step back, the universe is going to be getting smaller and smaller and smaller and smaller, until finally you get to a point where all the matter in the universe is congealed into a single point, and that marks the beginning of the expansion, and also the beginning of the universe itself. And so, contrary to the 19th century perspective that said that the universe was eternal and self-existing and it was infinite in duration and time going back, Hubble's discovery was the first of many indicators that the universe actually had a definite beginning, in fact, a definite beginning in time. And that established now what we refer to as the finite nature of the universe. It's not infinite in time, it's finite, it has a beginning.
Next was Einstein.
Well, Einstein has a very interesting role in this story, because he's the great, the guy with the bad hair that we all know, that is the icon of science itself. And he was working on a theory called general relativity in the teens, prior to Hubble. And as a result of this is a theory of gravity that implied that massive objects cause space itself to actually bend or create a curvature of space. And his theory implied that the universe was expanding and decelerating, as if a good illustration might be like a firecracker. You light it, you throw it in the air, it goes kabang, and then you have the paper shrapnel that first accelerates very quickly and then kind of flutters to the ground. And in other words, the implication of his theory and the math that described what the universe was doing implied that the universe was expanding and decelerating, but then if you wind the clock back again, that it had a beginning. So Einstein's theory and Hubble's observations converged on this conclusion that there must be a beginning. But the interesting part of the story is that Einstein didn't want to believe his own results. He didn't want to believe his own math. And so what he did is he posited an arbitrary value for one of the constants in his equation. His field equations of relativity, general relativity, implied that the universe was expanding. And it had to be expanding to counteract the force of gravity, because if we only had gravity, we'd all collapse into one big ball. So he posited not only gravity, but there was an expansion force, but then he posited another force of just the right strength to a contracting force that would counteract the expansion force. And that was called his cosmological constant. Now, he had no physical justification for this, no evidence to support this, but he was at the time strongly persuaded of the naturalistic, the materialistic worldview that said that the universe was eternal and infinite in time. And the idea of a beginning to the universe was just abhorrent to him. So he posited this as a kind of philosophical necessity to keep the universe static and thereby eternal in time. And he later learned that, well, he'd made a bit of a mistake on that. In fact, it was encountering Hubble that got him to change his mind again.
Einstein made up this cosmological constant, and yet later on, the evidence brought him back and showed him that he was wrong, and he admitted that he was wrong. What happened?
Well, it's a famous story. He was invited out to the Palomar Observatory in Mount Wilson in Southern California. Hubble had made these amazing discoveries about the expanding universe. He writes to Einstein and invites him to come out to see what he's seen. And there's some newsreel footage from the time Einstein goes out. He meets with these other scientists. The media is gathered there. He goes in. He looks in the telescope. This is all pre-staged, but when he comes out, he says, in his heavy German accent, he says, "I now see the necessity of a beginning." And he later announced that his fudge factor, the precise value that he set for the cosmological constant, was the greatest mistake of his scientific career, that instead of an infinite universe infinite in time, there was now decisive evidence from the heavens, from the telescopes, that there was a definite beginning to the universe, just as his theory of general relativity first implied. So he had these two strains of scientific discovery, one theoretical, one empirical, converging on the conclusion there must be a beginning, in stark contradiction to the key tenet of the naturalistic worldview that says that the universe is eternal and self-existent and infinite in time. So this is a huge challenge to scientific materialism.
Next week, we're going to turn the corner and we're going to talk about the fact is, yeah, that rubbed the scientists the wrong way because it knocked out their naturalistic, materialistic worldview. And so they fought back and they had other theories that they proposed. And we're going to look at those theories and we're going to see that science continues to refute those theories. So folks, join us next week. Welcome to our program. We're talking to Dr. Stephen Meyer, philosopher of science who got his PhD at Cambridge in England. He's written a best-selling book, Signature in the Cell, that we've been looking at in past programs, DNA and the Evidence for Intelligent Design. And he is talking about where did everything come from? Where did the universe come from? What is the latest scientific evidence? And why is this refuting the new atheists and the materialistic, naturalistic worldview? And Stephen, for folks that missed last week, kind of summarize that and then we're going to move on.
Well, the stunning discovery of early 20th century cosmology was that the universe has a definite beginning. And this discovery was made as a result of an observation that was first made by Edwin Hubble, an astronomer who was working in Southern California. And he began to work in the early 1920s using these great new dome telescopes that were being built then. This is the 200-inch dome telescope at the Palomar Observatory at Mount Wilson. Hubble was using a telescope like this that was able to capture large amounts of light from the night sky and therefore able to resolve little tiny pinpricks of light and show that those pinpricks had structure. And what he discovered was that in every direction of the night sky there were galaxies galore. There were spindle nebula and spiral nebula, and in fact if you zeroed in on any small quadrant of the night sky and then magnified that, you would find that there were galaxies just loaded in any little window that you might want to look at. And so that was the first discovery. But what was even more mind-blowing is the realization that these galaxies are moving away from us, that the further away they are, the faster they're receding. And the only way to make sense of that observation was to posit that the universe is expanding something like a balloon in what's called a spherical expansion. And so I have a little visual aid to review what we discussed last time, but basically, as you go forward in time, the universe is getting bigger and bigger and bigger, like this. Now that raises an interesting question, and this was where it got really interesting. And what happens if the universe is expanding as we go forward in time? What was it like at any point in the past?
You go back in time.
As you go back in time, it's like those old cartoons when suddenly the cartoon character would start backing up as the film was being rolled backwards. Well, if you roll the timeline backwards of the cosmos, you eventually get back to a point where all the matter begins to congeal into one place, and you get the beginning of the expansion, and in fact the beginning of the universe. Now, this observation or this conclusion was eventually reinforced by Einstein himself. Now, Einstein didn't like the conclusion at first. Oddly, he'd come to it independently because of the development of his theory of general relativity, a theory of gravitation that implied that the universe must be expanding and decelerating, much like the shrapnel from a firecracker as it blows out. But of course a firecracker begins with a bang. There was a beginning point. And Einstein initially didn't like this conclusion. He attempted to fudge it by introducing an arbitrary value for one of the terms in his equation describing the gravitational field of the universe. But he eventually came to realize that he was wrong when he was invited out to Southern California by Edwin Hubble, and he was brought to the observatory in Pasadena and was shown what Hubble was himself seeing through the telescope. He came out after a kind of staged demonstration in the telescope and announced to the media, "I now see the necessity of a beginning," in his heavy German accent. And he later said that missing this conclusion was the greatest mistake of his scientific career. In fact, he anticipated it in his great theory, but he ended up trying to fudge it by adding this arbitrary mathematical value. But that, he said, was the greatest mistake. So by the early 1930s, you had two powerful strains of evidence and theory that were confirming a definite beginning to the universe. And that was very upsetting to a lot of scientists.
Why was it upsetting?
Well, one of the first scientists to react to the what was soon called the Big Bang, well, later called the Big Bang Theory, was a man named Arthur Eddington. And he was a leading astrophysicist in Britain at the time, and he just flat out didn't like the idea that there was a beginning to the universe. This is what he said. He said, philosophically, he said, the notion of a beginning of the present order is repugnant to me. I should like to find a genuine loophole. I simply do not believe the present order of things started off with a bang. The expanding universe is preposterous. And then he said, it leaves me cold. And I love this quotation because Eddington, right out of the chute, tells you what's bothering him. You know, it's not. Sometimes I joke when I'm giving public presentations on this. I said, I'll say that Eddington's theory was what we call in the theory in psychology that we call denial. You know, he didn't really have any good scientific reason. It was just philosophically offensive. He was wedded to this 19th century worldview that we call scientific materialism, that posits that the universe is eternal and self-existent and has no beginning. And the scientific evidence was showing exactly the opposite thing, and it was upsetting to him. And another physicist explained a little bit more about why this was upsetting. This was Robert Dicke at Princeton in the 1960s, and he says, an infinitely old universe would relieve us of the necessity of understanding the origin of matter at any finite time in the past. That's what's at stake. If we have an infinite universe, we don't have to think about the universe beginning at a point in time, and therefore we don't have to think about what caused everything to come into existence. We can just assume that it was eternal and self-existent. But if there's a definite beginning, then we have established the need to explain the universe by reference to something beyond it. And that seems to point to a kind of a need for a kind of transcendent cause, which was uncomfortably like the notion of God for many scientists who were of this kind of materialistic or atheistic mindset. So that's the rub.
Stephen, define what a transcendent cause is of the universe.
Well, just simply, we're talking about a cause that's beyond the universe itself. If the universe is characterized by space and time, and then matter and energy within that space and time, a transcendent cause is something that is beyond those domains that we experience in the universe. So, you know, what we're talking about is unlike any other event. It's the origin of everything we know. It's the origin of the physical world itself. So if it comes into existence suddenly from nothing physical, then we have to either say it happened for no reason at all, it has no cause, which is kind of nonsensical, or else the cause of the universe comes from beyond it, from a transcendent realm.
Well, and obviously naturalistic, materialistic scientists didn't like that, and so they didn't like this thing of a beginning point.
Well, this is very, very troubling. I had the opportunity to attend a conference in 1985 where I heard Alan Sandage speak, and Sandage was first the student of Edwin Hubble and later a very prominent cosmologist and astronomer in his own right. He was deeply involved in verifying the expansion of the universe by showing that each of the galaxies in all different quadrants of the sky were in fact receding, were moving away. And when I heard him speak, he was describing the evidence for the Big Bang, for the definite origin of the universe and time, and he said this, he said, here is evidence. He looked into the camera, it was a very gritty kind of determination. He wasn't exactly happy about this when he was first discovering it, apparently, and he says, here is evidence for what can only be described as a supernatural event. What he meant was, this event points to a cause that lies beyond nature, because nature is what we're talking about here. Nature is what's been brought into existence. So, and he goes on to say, there's no way this could have been predicted or explained from within the realm of physics as we know it. It's pointing beyond physics. And that's
quite a statement right there.
It's an incredible statement, and it rocked my world when I first heard him talk about this. He actually was a long-time agnostic who'd come to belief in God because of, not in spite of, the scientific evidence.
Talk about Robert Jastrow.
Well, it's another guy in the field of astronomy and cosmology that saw the theistic implications of these new discoveries. He wrote a book called God and the Astronomers. And there's a famous passage at the end of his book where he kind of sums up the dilemma that many scientists felt as a result of the evidence for a definite beginning. He said, this is an exceedingly strange development. unexpected by all but the theologians, he says. They have always accepted the word of the Bible. In the beginning, God created the heavens and the earth. It is so unexpected because science has had such extraordinary success in tracing the chain of cause and effect back in time. But then you get to this beginning point, and there he says, it's like a bad dream. He says the story ends like a bad dream. The scientist has scaled the mountains of ignorance. He's about to conquer the highest peak, and as he pulls him up over the final rock, he's greeted by a band of theologians who have been waiting there for centuries. This was kind of ironic twist to the end of it. The theologians anticipated what the scientists in the end discovered, that the universe had a definite beginning, and it was very upsetting to many, many scientists.
All right, and we're going to take a break, and when we come back, we're going to talk about more of the scientific evidence. We're going to talk about Stephen Hawking and his amazing discoveries that even lays this in cement even further. So stick with us. We'll be right back. All right, back. We're talking to Dr. Stephen Meyer, philosopher of science, and we're talking about what scientists have discovered about the origin of the universe. And we've talked about the fact that the universe had a beginning, and it's been laid in cement almost by the scientific discoveries coming up to our time. And then there's another fellow by the name of Stephen Hawking, and he was at Cambridge as well, and he came out with some more evidence. What did he say?
Well, in 1968, Stephen Hawking solved what are called the field equations of general relativity, Einstein's famous equations, and I popped them on the screen here. There's Einstein next to his famous equation. And what Hawking showed is that as you go back in time, you eventually reach a point where what's called the curvature of space, or the curvature of space-time, as the physicists refer to it, gets so tight that it is infinitely tight. Okay, so if you think of the mass of the universe congealing as you are closer and closer to the beginning, then you have space curving tighter and tighter as a result of that mass. That's the theory of general relativity. Now, what Hawking showed is that at some point in the finite past, you reach a point where the curvature of space is so tight, it's infinitely tight. That's a circle so tight it has no volume. And now ask yourself a question. I used to ask my students this question. How much stuff can you put in zero spatial volume? How much stuff can you put in? Well, obviously, no stuff goes in no space. And you can see, therefore, that the Big Bang Theory, as it's conjoined with general relativity to be a description of the universe as a whole, implies not only that there's a beginning in time, but there's also a beginning to space itself, and with that, a point where there is no matter, no energy, where everything from that point forward comes into existence from literally nothing physical. And so what you have in the modern scientific description of the origin of the universe is remarkably similar to an old medieval doctrine, an old idea that the universe was created ex nihilo, out of nothing physical. The universe literally pops into existence out of nothing physical. That's the implication of Hawking's solution to these key equations of general relativity.
All right, Stephen, these were mind-blowing conclusions. What were the big implications of what Stephen Hawking was talking about?
Well, Stephen Hawking and the whole revolution in cosmology that's taken place with all the different evidences that have pointed to a definite beginning for the universe, I think point to the need for a transcendent cause of some kind. Again, a cause beyond the universe itself. And this is what most of the physicists have sensed. This is what's made them incensed about the discoveries in the new cosmology, pointing to a definite beginning. But every great worldview has to answer the question, what is the thing or the entity from which everything else comes? And as you look at the Big Bang singularity, as it's called, the beginning point of time and space and matter and energy, and you ask yourself, which of the great systems of thought, the great worldviews can explain that, you realize right away there's a huge problem for the materialistic worldview, the one that we've inherited from 19th century science, because materialism, first of all, affirms that the universe is infinite in time. Well, right away the Big Bang refutes that. But beyond that, it affirms that matter is the thing from which everything else comes. And yet, if you take Stephen Hawking's discovery seriously, you realize that if you go back far enough in time, you have an infinitely tight curvature to space, which corresponds to no spatial volume, and therefore there's nowhere to put any stuff. There is no matter in the early phase of the universe. It comes into existence suddenly from nothing physical. And therefore the materialistic worldview can't refer to anything as a cause that can account for the origin of the universe. The materialistic worldview says that matter is the end-all and be-all, the thing from which everything else comes. But matter comes into existence. It's the first effect, but it is not the cause of the origin of the universe itself. So that's a big problem. Pantheism, the Eastern worldview, also has a problem explaining the origin of the universe from nothing physical, because pantheism affirms that God is not a person. God is kind of the mystical unity that binds all of the material universe together, and God and matter are linked. They're coextensive. God is in the flowers and the trees. He's in our bodies. He's in the mountains. God and matter are coextensive, is the philosophical word.
God is all and all is God.
Exactly. But if you go back far enough and there's no matter,
There's no God.
there's no God. In both cases, with the materialistic worldview and the pantheistic worldview, there is no entity separate from the universe itself that can be invoked to bring the universe into existence, to act as a cause of the universe itself. And that's where I think that some kind of worldview that invokes a transcendent cause, like deism or theism, two worldviews that hold that there is a God separate from the universe that brought the universe into existence, are the only kind of worldviews that can really account for this evidence. And so deism is the idea that God created the universe and then has had nothing to do with it ever since, but God is still separate from the universe. And theism is the idea that God created the universe and has been actively involved in the universe ever since. But both of those worldviews posit the existence of an entity that is separate from the physical universe, and therefore they have what philosophers call the causal power to explain the universe as a whole. They posit an entity which has the capability of bringing the universe into existence out of nothing physical. Pantheism and materialism can't do that, and therefore I think the new discoveries in modern cosmology have incredible implications for these big philosophical questions that we've been debating all the way back since the ancient Greeks. Is the universe finite or infinite? And what's the thing from which everything else came? Mind, a power beyond the universe, or matter?
Stephen, this would sound like an ironclad case, okay? What's the main objection that has been raised against this?
Well, the main objection comes from a theory called quantum cosmology. And it's based on the observation that as the universe goes back far enough in time, it eventually would get to the point where it was small enough to be described by the equations of quantum mechanics. I often refer to it as the physics of the very weird, where the smallest things act like both waves and particles. And there are some mathematical equations that describe very tiny parts of matter in the way and the strange properties that they have. And when the universe is small enough, those equations would apply to the universe as a whole. And so some people have posited that when we get a theory of how gravity works at that level, it might supplant Einstein's general relativity, and we may get rid of the singularity. Now, the first thing you need to know is that we don't have a theory of quantum gravity, so we have no good reason to think that we will eventually get rid of the singularity, the beginning point. But beyond that, the quantum cosmology posits that in the very tiniest first micromilliseconds of the universe, that the universe is existing as a kind of oscillating, atemporal wave function. This is technical physics talk, but it's a timeless, non-isolating wave function.
Like in limbo.
Yeah, it's like it's in limbo, something like that. And what the equation of quantum mechanics is describing is the different possible geometries or gravitational fields that might have existed in that early non-time before the universe began in time. It's a strange way to think of it. But there's a big problem with trying to use this to get around the singular beginning. First of all, we don't have a theory of quantum gravity. But secondly, the equation of quantum mechanics that describes this early mysterious state is actually describing multiple possible states of affairs that might exist, multiple possible geometries or gravitational fields. Our universe has one geometry and one type of gravitational field. So to get from that state described by the quantum equation to the universe we have, something has to, what they call, collapse the wave packet, get rid of all the possibilities and actualize one. And in the standard, what's called Copenhagen interpretation of quantum mechanics, what collapses the wave packet, the thing that actualizes possibilities into one, is always an observation, which is made by a mind, a person. And so the implication, even if you invoke this quantum cosmological model, you actually end up positing the need inadvertently for a cosmic observer,
You still need one.
which is essentially the same thing as God. I mean, only God has those kind of capacities. The other option, and if you don't go with the Copenhagen model, you've got other problems, which is basically that you don't have any cause that brings the definite universe that we have into existence from an immaterial, atemporal state involving many possibilities. There's no explanation for going from the temporal, or from the timeless to the temporal, no explanation for going from the immaterial, this is just a mathematical equation, that's all it is, to a real universe that has matter and energy and stuff. And there's no explanation for the infusion of information that's involved in going from all that range of possibilities to an actualized universe. Because you're, in a sense, presented with a range of choices and you're choosing one. That's an impartation of information, and that's completely unexplained. So this quantum cosmological model either invokes a cosmic observer, or it requires an unexplained transition from no time to time, from no matter to matter, and an unexplained infusion of information. That sounds like, again, design.
All right, we're going to continue this, folks. If you find this fascinating like I do, next week we're going to talk about the next step of the scientific evidence that we've seen through the telescope, and that's the fine-tuning of the universe and how this plays into the equation. It's adding evidence on top of evidence for a theistic conclusion of where everything came from. You won't want to miss that, so please join us next week. Welcome to our program. We're talking to Dr. Stephen Meyer, philosopher of science who got his PhD at Cambridge in England. He's written a best-selling book, Signature in the Cell, that we've been looking at in past programs, DNA and the Evidence for Intelligent Design. And we want to carry on from where we've been talking about the beginning of the universe and the implications that science has given to us because of the beginning of the universe. We're going to turn the corner and add the evidence onto the evidence. And we're going to talk about the anthropic fine-tuning. What does anthropic fine-tuning mean?
Well, anthros is the Greek for man, and the idea is that the universe in its physical laws and constants, which we can talk about in a bit, are finely tuned to allow for the possibility of human life. It's as if the universe were a setup job to set the stage for the existence of life and the existence of human life. We've been talking in previous shows about the evidence for intelligent design in biology, in the digital code that's stored in the DNA molecule, and some of the other evidences. But what we have here in physics is evidence for intelligent design built into the very fabric of the universe. And this is highly significant because if you think about what the theory of intelligent design says is that some kind of intelligence was involved, it played a role in the origin of life. But from the evidence in biology alone, you can't decide whether that intelligence was immanent within the cosmos, some kind of space alien or intelligence within the universe as a whole, or whether the intelligence responsible for the origin of life was transcendent beyond the universe. What we have in the anthropic fine-tuning is evidence for design built into the very fabric of the universe itself. Clearly not something that could be explained by any being within the universe. And so I think it tips the scales in the direction of a theistic design hypothesis and points to the need for a God who is the designer, an intelligent agent who transcends matter, space, time, and energy. And so with the evidence from the new cosmology, from the Big Bang and general relativity, we saw that there was a need for some kind of transcendent cause. One candidate for that might be an agent that has the attributes we associate with God. With the anthropic fine-tuning evidence, we're going to see additional evidence that supports that thesis because it's also going to point not just to the transcendent nature of the cause, but also to its intelligence. And more succinctly, what I think the fine-tuning evidence shows is that there's compelling evidence for intelligent design in the entire universe, and it comes in the form of this fine-tuning of the laws and constants of physics and also of the initial conditions. And therefore, intelligent design provides the best explanation for this evidence. And I'm going to go further and say that the kind of design that's necessary is a design that transcends the universe as a whole, and therefore we're looking at something that is decidedly theistic. We're looking at a God hypothesis.
Okay, one of those things that backs it up is the expansion of the universe, the rate of the expansion of the universe. Describe what that is.
That's a good place to start because we've been talking about the expanding universe in previous programs, and it turns out that the rate of expansion is finely tuned to allow for the possibility of life. If the universe were to expand even a little tiny bit faster, then the universe would dissipate. The heat and energy of the universe would dissipate too quickly, and we wouldn't form stable galaxies. If it had expanded a little tiny bit slower, we would have gotten a big crunch. The gravitational forces would have overcome the rate of expansion, and all of the universe, the matter in the universe, would have crunched back on itself. So it turns out that the fine-tuning of the expansion rate of the universe is exquisite. It's fine-tuned to 1 part in 10 to the 60th power. That's about the same as $1 out of a trillion dollars. Now, of course, with the federal budget deficit and everything, that may not seem like that much to people today, but this is exquisite fine-tuning. If you're an engineer and you're familiar with the concept of tolerances, you realize that the tolerance here for error is minuscule, and yet the universe is just right to allow for the possibility of life.
This is also called a cosmological constant.
Well, the expansion rate of the universe is related to a deeper, more fundamental parameter called the cosmological constant. That's the constant that Einstein was fiddling with to try to restore a static balance in the universe, fiddling with in his mind, not in reality. And yeah, that's a very important fine-tuning parameter.
It's actually the balance between the expansion out and the pulling back in.
Exactly. And our universe is finely tuned so the expansion just barely exceeds the contractive force of gravity. And it turns out you need that finely tuned just as the way it is to allow for the possibility of life.
But that's not the only anthropic fine-tuning principle that the scientists have found. What are some of the others?
Well, there are about 25 to 30 of these separate parameters that are each exquisitely finely tuned to allow for the possibility of life in the universe. And in each case, there's a kind of a not too hot, not too cold aspect of it. If you think back to Goldilocks, we're the Goldilocks universe. For example, with the gravitational force constant.
It's just right.
It's just right. It's just right, and it's right over and over and over again with these many separate parameters. For example, with the gravitational force constant, if it's fine-tuned to about 1 part in 10 to the 40th, which is, again, an incredibly small tolerance. And if the gravitational force is larger, then stars would be too hot, they'd burn up too quickly and too unevenly. If the gravitational force constant is smaller, then stars would remain too cool so that nuclear fusion would never ignite, and hence we'd have no heavy element production, therefore no planets like our own. So in each case, if you get it off by a little bit, then something bad happens that would make the universe impossible. Now, many people aren't familiar with the idea of constants because you got to kind of be a physics geek to be into this. But basically, every equation has a proportion between one variable and another, and there's a quantitative aspect to that proportion that's expressed by what's called a constant of proportionality. So you could imagine, I used to admire the Russian pole vaulter, Sergei Bubka. Now imagine that Sergei is running down the tarmac, and he's a man of about 200 pounds. The Earth has a given mass, and therefore there's the proportion between those two masses generates a particular force, or there's a force generated between those two masses. But the gravitational force constant tells you how much force is generated given everything else being equal, Sergei's weight and the weight of the universe. Now imagine Sergei's running down the tarmac, ready to do his jump, and somebody fiddles with the gravitational force constant and makes it pull gravity twice as hard as it would otherwise do. What's going to happen? Well, he's going to come crashing to the Earth. Imagine somebody twiddles the dial the other way. Now he's going to sail way above and set a new world record. So what physicists realize is that these constants have precise values that determine, for example, how strong gravity is, and they could be otherwise. And as they examine them carefully, they realize if they were even a tiny bit different in either direction, a little bit stronger, a little bit weaker, life would be impossible in the universe. And that's true not just of gravitation, of the expansion rate of the universe, it's true of numerous separate factors, whether we're talking about the speed of light, the ratio of fundamental forces in physics, all kinds of different things. And that's what's so striking about this.
All right, Steve, you got a great illustration of what you're talking about. Show the folks.
Well, it's really from John Polkinghorne, one of the leading physicists from Cambridge University. I've simply made a visual to go with the idea, but in order to get across the idea of the anthropic fine-tuning, he asks his readers to imagine a universe-creating machine. And maybe you're out in space. You're going to you land at a space station, and you go inside, and there's a room that says Universe Creating Machine. You go in, and each one of the dials, there's dials for every one of the fundamental forces of physics. There's a dial for the expansion rate of the universe, for the gravitational force constant, for the ratio of the different fundamental forces. There's a little slider for the speed of light. And it turns out that each one of these is set to a very precise value. And since you're a physicist, you take out your pencil from behind your ear and start making some calculations. You realize, if we changed any one of those values, if we spun the dial a little tiny click this way or a little tiny click that way, move that slider a little bit one way or in the other, life wouldn't be possible. Now, what do you make of that? Now, Polkinghorne, he has a charming way of saying it. He says, well, I don't say that the atheists are stupid. He says, I think that theism, the theistic design hypothesis, provides a better explanation. Mm-hmm. And this has been a kind of universal reaction among physicists at a kind of intuitive level. Fred Hoyle, the famous British astrophysicist who spent a lot of his career trying to get around the implications of the Big Bang Theory by posing other models to explain away the beginning of the universe, eventually came to realize that the fine-tuning evidence provided compelling evidence of design. Hoyle says that a common sense interpretation of the data suggests that a super intellect has monkeyed with physics and chemistry as well as biology to make life possible. And I always get a kick out of this because the monkeys always seem to make it into the origins debate, even when we're talking about physics. But I think Hoyle's exactly right here. A common sense interpretation of this fine-tuning suggests that there was a fine-tuner, intelligence, a super intellect that was responsible. And since the evidence of design that we're looking at is built into the very fabric of the universe, right from the very beginning, I think what we're looking at is not something that can be explained by any designing intelligence or agents within the cosmos. Richard Dawkins has, thrown out the idea that, well, maybe there might be an alien intelligence that's responsible for what he calls the signature of intelligence in life. That kind of intelligence can't explain this evidence. This evidence points to the need for an intelligence beyond the cosmos that could build the design into the universe as a whole. So I think this is a compelling new development in science that has, again, very positive theistic implications.
Folks, this is fantastic information. I hope you're catching the drift of all of this and what it means. But we're going to take a break. When we come back, we're going to talk about there are still objections to this evidence. And we'll hear about that when we come right back. All right, we're back. We're talking with Dr. Stephen Meyer, philosopher of science, and we started this series. We talked about Richard Dawkins saying there's no evidence for a designer. You got a garden, you got no gardener. And what we're seeing here when we look at the universe is we got a ton of evidence. We've got all kinds of evidence, exquisite evidence, okay, that there is a designer, there is a cause, a creator that's beyond time and space. Now, you say, what could be thrown against this? And they've come up with the multi-universe theory. What is that? And you've got a great animation with Jay Richards about this, folks. I want you to watch.
As its name suggests, the theory of multiple universes proposes that our universe is not alone. Instead, it is part of a vast ensemble of universes, each with a different set of laws and constants.
If there's only one universe, then the conclusion that the universe looks fine-tuned because it is fine-tuned is inescapable. But if our universe is just one of a vast set, then you seem to have more resources to play with. Chance gets a new lease on life. I sometimes try to imagine what physicists have in mind that postulate this idea of multiple universes. I mean, what would the generator look like that creates them? Maybe it's like a giant monolith that has dozens of different dials, each of which has to be set to the right physical constant.
If we think of these parameters as dials, each of the dials is different. So if you produce enough universes with enough different dial settings, eventually, just by chance, you get one just right. So you might have to produce a trillion universes. But eventually, if you have a generator that's just spitting out just an enormous number of them, then it gets the right dial setting. And then by just chance, you get conditions right for life. So it's a huge cosmic lottery. That's the idea.
All right, Stephen, as we watch that, that's a fantastic illustration of what you're talking about. But what would be the generating machine, if there was such a machine, to generate all of these universes?
Well, right. Physicists have two theories that have been proposed that would suggest that there might be other universes. And one is called inflationary cosmology, and that was a theory that was posited to explain some of the observable effects of the universe. And the idea was that after a very short time after the Big Bang, there was a rapid expansion in the spatial volume of the universe. And the idea there is that there is something called an inflaton field that shuts off with a precise energy, and as it shuts off, it generates a new universe. And another theory is the idea of string theory, which posits that the fundamental particles in the universe are actually little tiny strings of energy, and that they have different ways of turning on themselves and forming little compactifications of space and the like. So
We see that on public television all the
yeah,
time.
there's all kinds of stuff on string theory, but string theory implies that you could have a decay in what's called the string vacuum, and that would generate new universes. So these two theories have been proposed as the universe generating mechanisms.
What's wrong with that now?
Well, what's wrong with it is the theories may have some merit on their own terms, but what's wrong with them as an attempt to explain the fine-tuning is they really don't. Not completely adequately. The inflationary cosmology accounts, or might account, for the fine-tuning of the initial conditions, the initial configuration of matter at the beginning of the universe, but all the new universe it generates has the same laws and constants of physics that we have, so it doesn't explain the fine-tuning of the laws and constants of physics. String theory has the opposite problem. It explains the fine-tuning of the laws and constants of physics, but it doesn't explain the initial condition fine-tuning. So in order to account for the whole fine-tuning problem, you have to conjoin these two theories, both of which have some highly speculative theoretical postulates. And one of my colleagues, who's a philosopher of physics, has actually made a list of what he calls the 6 unobservable things you have to believe in before breakfast if you're going to account for the fine-tuning apart from this simple postulate of a theistic designer. For example, you have to believe in the existence of other universes. You have to believe in the existence of an inflaton field. You have to believe that the inflaton field is finely tuned in its shutoff energy, which it raises an interesting point because each of these models, in their attempt to explain fine-tuning, actually presupposes other fine-tuning. So it just really just pushes the problem back. You have to believe in strings. You have to believe in extra dimensions of space, 6 or 7 of them. You have to believe that each compactification of space in string theory corresponds to a different universe with different laws and constants of physics. All of these are pure theoretical postulates for which there's no direct evidence. We only would posit them because they might help us explain other things. And so you have to somehow merge these two theories and believe the whole suite of postulates rather than the simple hypothesis of theistic design. In that first clip you showed, in our previous show of Richard Dawkins, he was saying that, well, that Darwin's idea of design without a designer provides the most parsimonious explanation of the evidence. Well, parsimony refers to simplicity. And what you find when the attempt to explain away the fine-tuning apart from a designer is you get an incredibly convoluted explanation involving multiple theoretical postulates involving unobservable entities for which we have no direct evidence. So it fails the parsimony test that Dawkins laid out. In addition to that, though, there is this problem of pushing the design back one generation. In both in string theory and in the inflationary cosmology, in order to explain the fine-tuning, you have to posit certain processes which are themselves finely tuned to generate universes or a universe like our own. And so my colleague Robin Collins, who was in that video clip, he's developed an interesting illustration to get this across. He says, imagine you've got a loaf of bread, and you say, man, so whoever cooked that had the right recipe. They put it together. That loaf of bread was designed well by a great cook. And you say, well, no, that loaf of bread wasn't intelligently designed. It was produced by a bread-making machine that did it all by itself. But what's the problem? Well, obviously the bread-making machine with all its components and its ability to harness electricity and its ability to use a recipe is itself a design system. And so you really haven't gotten rid of the evidence for intelligent design, you've just pushed it back one generation. And that's precisely what these physical theories do in their attempt to posit some mechanism that could generate new universes.
All right, Stephen, summarize all of this. What do you want the folks to walk away with?
Well, first, the scientific evidence in physics for intelligent design is very compelling, and that intelligent design provides a better explanation of the fine-tuning than the competing naturalistic hypotheses like the multi-worlds hypothesis. But second, if you put this in a larger perspective, we now have another piece of evidence that I think points in the atheistic direction, because what we're looking at here is evidence that cannot be explained by any designing intelligence within the cosmos. Instead, what we're looking at is intelligent design, or evidence of design that's built into the very fabric of the universe. So if you go back to one of my worldview diagrams that we looked at before, and we look at the different competing worldviews and we treat them like metaphysical hypotheses, we see that, again, naturalism can't account for this because it doesn't posit anything beyond the universe that is intelligent that can explain the fine-tuning. Pantheism has the same problem because the pantheistic God is inherent in the physical universe itself. It's coextensive with matter. And so, again, you need to posit an entity which transcends the universe and which is also intelligent. And again, the two worldviews of theism and deism both posit the existence of such an entity, and therefore I think they provide the only adequate explanations of both the Big Bang singularity and the fine-tuning of the laws and constants of physics and the initial conditions of the universe that we've been discussing today.
All right, if you noticed, we left deism and theism hanging. We're still talking about who's in competition and who's going to win that fight. Okay, where does the scientific evidence lead us? Next week, we're going to talk about that, so I hope that you'll stick with us. Welcome to our program. We're going to talk today about the question, do you believe that the scientific evidence from biology and cosmology actually points to an intelligent cause of the universe and of life itself? And if you've been with us for the last series of programs, we first of all took biology, and then we went into cosmology, and today Steve is going to summarize both of those and put them together and then talk about which worldview, in the end, it's pointing to. So Stephen, start us off.
Well, you bet. We've looked at evidence of design in biology. We've seen that there's evidence of design in physics built into the very fabric of the universe. We've looked at evidence for a definite beginning to the universe. And I've been fascinated with this for years. I first encountered this kind of new perspective on science at a conference in 1985. And so I've been thinking for years about which worldview makes best sense of the experience that we have of nature, of these big discoveries about the origin of the universe, the fine-tuning of the universe, the origin of life, and other evidences of design that I will want to talk about today. And so maybe a good place to start is just by talking about the competing worldviews. If you treat a worldview, first of all, is a coherent set of answers to some basic questions. Questions about, for example, ultimate reality. What's the thing from which everything else came? What's the entity from which everything else came? And as you look at the evidence from nature, there are a number of different worldviews that you might posit to try to explain what we see in the natural world. And we can summarize those briefly. Materialism is the idea that matter and energy are the entity from which everything else comes, and you can kind of represent that graphically if you look at, you represent the universe as a big circle, as I've done here with these kind of cartoons. And the pendulum there represents the laws of nature, the people and the planets and the trees and the mountains. That represents all the physical stuff in the universe. And the key tenet of the materialistic worldview is there's nothing beyond the physical world that exists. There's no God, there's no purpose or entity that could provide a purpose for the universe. The fundamental entity from which everything else comes is matter and energy. Now, there's a contrary worldview that is kind of on the other end of the spectrum, and that's theism. Theism holds that there is an orderly concourse of nature, thus there are laws of nature, again represented by the pendulum going back and forth, but that the universe is not autonomous and self-existent. That beyond the universe there's a God, and that God acted to bring the universe into existence. That's the middle arrow in the little diagram. that God underwrites the order of nature, that God sustains the universe in its orderly concourse, and in fact what we call the laws of nature are nothing more than a mode of God's action, a mode of divine action. And thirdly, there's an arrow that suggests that God periodically enters into the creation that he otherwise ordinarily sustains and upholds. So God acts as an agent within the created order from time to time as well. That's the theistic worldview. Now there are two other worldviews that have been very dominant in the thinking of our civilization from time to time. One is the deistic worldview that holds that there is a God that's separate from the universe, but that God never acts within the cosmos. This was the clockwork maker idea of the 18th century, that God, in a sense, wound up the universe, designed it at the beginning, but then let it on its own and never had anything more to do with God. It was all a setup job from the beginning, and nothing was done beyond that. And then there's the great Eastern worldview called pantheism, and that worldview says that there is a God, but God is impersonal. God is not a mind or a personal agent, is not conscious, it's not someone to whom you can communicate through prayer or any other means. And instead, God is the mystical unity that binds all things together. All matter is in God, all God is in matter, and that's the pantheistic perspective. So we've got these four great systems of thought. And what I've been curious about for years is which one best explains the evidence that we have in the natural world. You can treat a worldview also as a kind of metaphysical hypothesis, an explanatory system. So which one accounts best for these amazing discoveries that have been revealed by 20th century science? And so let's just quickly review those discoveries, the very things we've been talking about in the preceding programs. One is the discovery that the universe has a definite beginning. This was first discovered as a result of Hubble's observation that the universe is expanding in all directions. The galaxies are expanding, and if you wind the time clock backwards, you ultimately get to a beginning of the expansion and a beginning of the universe. That was something that Einstein came to realize, somewhat reluctantly, as we discussed. Another great discovery is the realization that not only is there a beginning to time, but there's a beginning to space itself. That as you go back far enough in time, the curvature of space becomes infinitely tight, corresponding to zero spatial volume, and thus you have a true singularity at the beginning in the words of the astronomers, and that also cries out for explanation. It seems to point to the need for some kind of cause beyond the universe itself, or the universe as a whole, because you can't put much matter in zero spatial volume, in fact none at all. So a materialistic explanation would seem to be kind of off the table. So that's one of the great discoveries. The other thing that we talked about is the fine-tuning of the laws and constants of physics, and the fine-tuning of the configuration of matter at the very beginning of the universe. And what physicists have realized since the 1960s is that the universe is finely tuned to allow for the possibility of life, such that one famous physicist, Fred Hoyle, said that a common sense interpretation of physics, of the data, suggests that a super intellect has monkeyed with physics and chemistry and biology to make life possible, that the universe looks like a setup job. So that's a second huge discovery. So as I looked at the competing worldviews and asked which one of the four great worldviews could account for this evidence, I realized, through a process of deliberation, that both materialism, scientific materialism, and pantheism have a hard time accounting for both of these two classes of evidence because they don't posit the existence of anything beyond the universe, and still less anything intelligent beyond the universe. And yet the fine-tuning cries out for intelligence, and the cosmological singularity cries out for a cause beyond the universe, a transcendent cause. So when you take those two pieces of evidence together, it looks to me like only theism and deism provide an adequate explanation because they posit an entity beyond the universe itself which can act to bring the universe into existence.
Stephen, in adjudicating between theism and deism, what other evidence do you have? Let's go back to biology and summarize that for a moment, too.
Well, that's really where the key evidence lies, because we realize that the origin of life took place some time after the origin of the universe. We're talking about evidence, if we see evidence of design in biology, that evidence that would point to not a deistic creator which confined its activity to the very beginning of the universe and then had nothing to do with the universe ever thereafter. That would imply some kind of agent that is acting after the universe has come into existence, either a theistic designer or some kind of imminent designer, a space alien or something. I think we've already provided evidence that we
Can't be a space alien.
It can't be a space alien because we've got evidence built into the fabric of the universe of design. That can't be explained. So if you want a hypothesis that explains all the classes of evidence, I think you need to invoke a theistic design hypothesis, but you can't see that until you realize that there's strong evidence of design in biology as well as physics and cosmology.
And what is it?
Well, that's what we talked about in the first series of programs that you brought me to here earlier, and that's the evidence of design that you find because of the information that's embedded in the DNA molecule. Francis Crick, 1957, he proposes what's called the sequence hypothesis. He proposes that along the spine of the DNA molecule, the four chemicals that are present there, the so-called bases, are functioning just like alphabetic characters in a written language or digital characters in machine code. His hypothesis is eventually confirmed. Biologists today now realize that it's information that's running the show inside life. The digital code in the DNA molecule is essential to living functions, and to get life going in the first place, you've got to account for the origin of that information. Now, in my book, Signature in the Cell, I discuss this at great length. What I tried to do in the book was to show that there's a positive case for intelligent design based on this critical discovery. And I actually developed this case using the method of reasoning that Darwin himself used in his book, The Origin of Species. It's a scientific method for investigating events in the remote past. If you want to find out what caused something to happen a long time ago, you need to identify a cause which is capable of producing the event you're trying to explain. And the key thing we're trying to explain in The Origin of Life is the origin of the information that's necessary to make life possible. And Darwin's principle, which he got from his mentor Charles Lyell, was simply that you've got to find a cause which is capable of producing what you're trying to explain. Lyell put it this way. He said we should be looking for a cause that's now in operation. And when I saw that phrase in Lyell's, on the front piece of his book, I realized, wow, it's possible to make a scientific case for intelligent design, because what we know from experience, which is the basis of all scientific reasoning, is that information always arises from intelligence. In fact, one information scientist put it this way. He said the creation of new information is habitually associated with conscious activity. Well, now, step back for just a minute. What do we have in the history of life but an infusion of new information that is necessary to get life going? And that, most scientists date that occurrence in the origin of the first life at about 3.85 billion years ago. Well, that's 10 billion years after the Big Bang. So if it's not a space alien who is the designer, it's clearly not a deistic creator either, because a deistic creator confines its activity to the beginning of the universe and no other time. So what we're looking at is evidence of design, which when coupled with the evidence that we've seen from physics of design that's built into the very fabric of the universe, is pointing in a decidedly theistic direction towards a designer who not only acted at the beginning of the universe, but who is also capable of acting after t equals 0, after the beginning of the universe, and within the history of the cosmos, because that's what we see in biology, is evidence of design that arose in the history of the cosmos well after the beginning.
All right, we're going to take a break. When we come back, we're going to talk about more evidence. We've talked about chemical evolution. Actually, how that first cell start? Okay, you just nailed that one down. But you also have a whole series of bits of information about biological evolution, and we want the folks to see that, and we're going to talk about that next, so stick with us. All right, we're back. We're talking with Stephen Meyer, philosopher of science, and we're talking now about biological evolution, all right? We've shown that chemical evolution can't occur by chance, all right? But what about the development later? It seems like there's a problem over there too, and you've got a great illustration, and it goes back to helping us decide, adjudicate between theism and deism. What is that?
Well, right. I think the crucial question is, again, design. And where do we find design in the universe? And I've got a little timeline on the screen that I think helps. You think of a locus or a loci of design, places where design is evident. And if design is only evident at the origin of the universe, then you could invoke a deistic kind of conception of the designer, a deistic God, as an adequate metaphysical hypothesis. If design is only evident in life but not in the universe, then you might invoke a space alien or something. But if you've got evidence in both places, I think you really need a concept of a theistic designer to account for the evidence. A designer is capable of building design into the very fabric of the universe and then acting after the universe has been created to implement other design, to bring that into existence. And that's what we see in the case of the origin of the first life. I think there's compelling evidence of design there at the point of the origin of the first cell, and that's what my book, Signature in the Cell, is about. Mm-hmm. But I actually think that there's evidence of design further down along the timeline. In addition to the evidence for design at the beginning of the first life, at the point of the origin of the first cell, I think there's compelling evidence of design in the origin of the major animal body plans, an event that's known to paleontologists as the Cambrian explosion. This event is dated about 530 million years ago, well after, again, the beginning of the universe. So we've got evidence of design arising sometime well after the beginning of the universe. And let's have a look at what biologists are discovering there. This event is called the Cambrian explosion, and basically what happens is that in a very narrow window of geologic time, between about 3 and 6 million years, the major new anatomical novelties arise in the history of life. There's a group of about 19 to maybe 30, depending on how you count, new body plans, new body architectures that come. They're the first animals, and they come into the Cambrian fossil record all around the world at roughly the same time in this very narrow window of time. And this presents a tremendous problem if you're trying to explain this from a Darwinian point of view for a number of reasons. First of all, it doesn't match the Darwinian picture of the history of life. Darwin's idea was that there was a beautiful tree that described the history of life, that one form of life morphed gradually into another one. But when we're talking about these first animal forms, they arise suddenly without any ancestral precursors that in a sense, announce their coming. There's no gradual morphing evident in the fossil record at all.
You got a blast of new information.
You have a blast of new form, which requires information. So that, again, is the big question, where that information come from. If mutation and selection can't account for it, and I'm convinced, and many other scientists are convinced that it can't, well, what other explanation is on offer? Well, again, I think this is where intelligent design has something to offer, because we know from experience that large infusions of information are the product of mind. We know of a cause which is capable of producing the effect which is on display in this Cambrian event, this Cambrian explosion. Mm-hmm. So I think it's another evidence of intelligence, because you've got new form which requires new information. You've got a lot of it coming into the fossil record very suddenly. I think that's pointing to intelligence.
And Stephen, isn't it true that that's the case all the way up the line?
Well, there are many other examples of large innovations in new biological form arising in the history of life. And every time you have a new innovation in form, you need new arrangements of cell types, you need new cell types, new dedicated proteins, and therefore at least a lot of new information in DNA, and maybe even information that's expressed at higher levels in the biological hierarchy. So new form requires new information, and we have many events where you have a sudden emergence of new form. For example, the mammalian radiation. You get between 13 and 15 new orders of mammals about 50 to 55 million years ago. You have the origin of flowering plants, what's called the big bloom in the Cretaceous. You have the origins of different groups of insects come very suddenly into the fossil record, and the origin of marine reptiles. Many other groups come into the fossil record very suddenly. In each case, they require a lot of new form, a lot of new structure, and therefore a lot of new information. And I'm increasingly convinced that the Darwinian mechanism of mutation and selection does not account for that. And instead, we're seeing a feature that we know intelligent design does readily account for. And therefore, I think we're seeing evidence of intelligent design at multiple instances along the cosmic timeline.
Stephen, is there any other evidence from biology that shows design?
Well, there's another whole class of evidence, and it's the nanotechnology that we're finding inside cells. My colleague Michael Behe has made some of this famous in his book Darwin's Black Box, but there are many examples of these exquisite molecular machines inside living organisms. For example, this is what's called an ATP synthase. It's the machine that makes the battery packs that provide the energy that keep all of our cells alive. We have these in the membrane of our mitochondrial cells, and there's a beautiful rotor, which creates a torque on a shaft, which creates a conformational change in proteins, which opens up a beautiful pocket into which two molecules fit exactly right. The pocket closes, they combine, and then they're released, and there you've got an energy source for the cell. There's machinery like this, rotary engines, sliding clamps, little robotic walking proteins. The cell is chock full of digital or of nanotechnology that gives every appearance of having been designed. And I personally don't think that this has been explained well by mutation and selection either.
Where does this leave us in terms of worldviews?
If you realize that we're seeing evidence of design at several places along the cosmological timeline in the living world, the origin of the first life, the origin of the Cambrian animals, the origin of other major groups of animals, the origin of these miniature machines. What you're seeing then is evidence of design that's not just confined to the very beginning of the universe with the fine-tuning laws and constants of physics, but you're seeing design that is infused in the cosmos at episodic intervals throughout the history of the cosmos. And therefore, we're not seeing evidence of design that can be explained by a deistic creator. We're not seeing evidence that can be explained by any worldview that denies there is an intelligent cause. Instead, we're looking at evidence that requires a designer who acts at the beginning of the universe and who also acts after the beginning of the universe. And that sounds to me a lot like a theistic designer, a designer who has the attributes that religious believers have typically associated with God: transcendent, intelligent, and active in history. And I think that's one of the reasons that you're seeing many people moving away from the so-called new atheism, which I think is really the old atheism. For example, Anthony Flew, who was a longtime atheist, who came to realize that there was compelling evidence of a creator in the physical world, both in cosmology and biology. The historian Fred Burnham has said that the God hypothesis is now a more persuasive and respectable hypothesis than at any time in the last 100 years. I agree. I think it's not only more respectable, I think it's the best explanation of this ensemble of critical evidence from cosmology, physics, and biology that we've been able to discuss on your program.
Stephen, I want to say thank you to you for coming. All the folks that are watching, I'm sure, realize you're just a brilliant, brilliant man that God is using, and we appreciate you coming and delivering all this information to us. It's been a privilege to have you here.
It's been a privilege to be here and to have this great conversation and a chance to talk to all the people that you reach through your terrific program.
And folks, I'm glad that you did join us today, and I hope that you'll join me again next week.